Good? You ready? Ready for some more Fast and Furious?
Yeah.
Here we go. One, I want to let you guys know for your homework, if you've already started. If you haven't, then I guess it'll be a surprise, or not even a matter. But I had a thing on the first bullet point, which is to create your UML diagram. Disregard, I took that out and changed that. So you don't have to worry about that till next week when we actually talk about it. That'll make a lot more sense to you then. It won't really make sense to you this week. So I took that one out. Everything else is still the same. And so we'll talk about most of those things today so that hopefully you have a good idea what you should be doing. You should just extend what you did last week, which of course I haven't finished grading yet, but hopefully I'll have it done by tomorrow. I apologize. I got a little sidetracked, but I'll get there. So, questions. How are things going? You guys are all right? Yeah? Everything's crystal clear? We're on chapter 3, which chapter 3 is now dealing with how do we deal with classes that have already been created for us. We dealt with one already, right? Which was what? Scanner, right? So we use a scanner to be able to get input. Well, we're going to do the exact same thing. You're going to see this pattern. The nice part is this pattern will repeat itself regardless if it's somebody else that made it or we make it. So we'll create classes later, next week actually, and then we'll use them. But we're going to take a look at a couple of classes that exist for us. We've already looked at scanner, and we've already looked at string. Now, there's something else that we should probably talk about with these, and then is that we know that we have either primitive types or object types. These being which type? Object. And how do we know that?
Do stuff.
Because they can do stuff, right? They either have methods or attributes that go inside of it, whereas your primitive types can't. Okay? Now, one of the things that we did is, remember when we just did this, we did like string and then name, right? We can do that. And we can say equals to Bob or whatever we want it to be. You also can do this. And this should look much more familiar to what we did with the scanner, equals new string. That's what's sort of happening, right? So we can either assign it a string literal or we can create a new instance of this. Now, what's important to note here is that when we create something like this, very like that with the semicolon versus something like this, like an int a, what's the difference between these two, number 1 and number 2? Int a and scanner, my scanner. What's the difference between those two? Besides one's a primitive and one's an object. What's happening? Does anybody know? What's happening in regards to memory space? Bless you. What do we know about memory space and primitives? It does sometimes take up less, but there is an automatic allotted amount, right? So the moment you create a primitive type, it knows just how much memory space to set aside. So that means that when we declare a variable like int a, memory space has already been declared, even if it doesn't have a value. But when we do something like this, like scanner my scanner, no memory's been allocated yet because we haven't said new scanner. Until we do that, no memory's there. So that means that the moment we do something like that, scanner my s equals new scanner. We're going to use the scanner a lot, by the way, for other stuff. This is just the first version of it when we get stuff. When we do this, now we've created memory space, and now this points to it. Hence the name pointer. You're going to see this. We're going to see this name, this convention, again and again whenever you deal with, say, any object-oriented language, whether it's C, C++, well, not C, I guess, but they do have pointers. But then you'll see it in VB, you see it in, it's just that it's sort of hidden from you. But know behind the scenes that memory space is allocated only after you create the instance of that class, and that points to it. Okay? What's important to note about that, and this will become even more important when we get to like methods and stuff, is that when you do something like this, knowing what you know now, if I say this, and then I say this, then I say this, what happened in memory space? What's that? B points to the same memory space as A?
No.
Is that true?
There's now.
We have a no. We have a yes. Or, you got a 50-50 on this one. It's always a 50-50.
No, there's now.
Knowing what you know. So we know that an integer is going to set aside memory space the moment you declare it. So it did the exact same thing here in B. It just so happens to have the value of 3 and 4. But the moment you assign A to B, now B has the value of A. But that memory space still exists. We still have 2 memory spaces. Okay? Does that make sense? Now, keep that in mind. If we do something like this, scanner my S equals new scanner system.in, and then we have another scanner my S2 equals new scanner system.in, and then I say my S2 equals my S. What did I do here? Want to say it louder?
You're making a point to the other one now.
Now, who's pointing to who? How many memory spaces do I have as I walk through there? 1 or 2? 2? Who says 2? Well, a lot of you say 2. Who says 1? A couple of you say 1. Why is there 2? Be brave. Because I created 2 new instances. Okay, I'll give you that. So there's 2. What happened there? What happened on that third line? Do I still have 2 instances?
Yeah.
Yes?
It's just nothing's pointing to it, and eventually it's going to get rid of it.
Ah. So what happens is now this and this, they're pointing to the same memory location. Because they're pointers, they point to the exact same place. Right? Wherever S was pointing, which was this one. This one then gets picked up by what's called garbage collection. GC. We don't know when garbage collection comes around in Java. It just does.
Don't worry about it.
Don't worry about it. But that's why you don't see too many first-person shooters in Java. Because why do you suppose? You're going along, you're shooting somebody. Not real. And all of a sudden it has to pause because garbage collection comes around to pick up the loose memory. You're like, that wasn't fun. That's why you don't see that. But in C, C++, the reason why it's faster, infinitely faster, is because you have to release the memory yourself, or else you get what's called a what? Memory leak. And if you've ever worked with Windows NT way back in the old days, they were very good at that. And SQL Server did the exact same thing. And what you do is you right-click and you look at your memory, you know, your system settings, and you look at your memory usage and your CPU usage, and you just sit there and let that run for a few days. And it would just climb and climb and climb, and your memory would run out of, you'd run out of memory, and you'd have to reboot your server every so often, which that's fun for clients. Don't worry, we just have to reboot. Yeah. No. I wish there was a good way. Not really. It just kind of does it on it's basically trying to like do it behind the scenes for you so that you don't have to think about it. Like you can just throw it away and it'll just come and pick it up. When it assumes that it's not being referenced by anything anymore. That's essentially what it's trying to do in an optimized way. So, yeah. But what we've done here is what we've created an alias. What's that mean? What does alias mean? Ooh, almost drank that.
2 names for the same guy.
2 names for the same person, essentially doing the same thing. We have 2 things pointing to the same place, hence an alias. We cannot do an alias with primitive types because we are copying values. This will become much more important when we start doing something what's called copy by reference or copy by value or something like that. And so when we go into methods, this will become much more important, especially when we're talking about arrays. Does anybody know what an array is? You guys did them, right, in Python? What are they? They're like a list, right? Lots of stuff. right? When you copy it, if you were to pass that into a method, and let's say we did it like in primitive, where we just copy it from one thing to another, what would have to happen? What do we do here? What do we do here? How many memory spaces did we end up with? Regardless, even when we assign one to the other. We still had 2, right? So if we copied a list and we did it by copy by value, we would have 2 lists, right? Not bad, right? It's only like, say, 5 things in a list. Now expand that to like 5 million things in a list. Now call that 10 million times. Okay? Do the mental math on how much memory space you just used in those 3 lines by calling a method that copies that stuff all over, and you call it 10 million times. How fast is your program going to run? Not well. I can promise you that. So what we do instead is we move it by reference, hence we're just sending a pointer. And so we don't have to make more memory space. We have the one single memory space. We move the pointer into the method. And even if we call it 10 million times, we're only dealing with that one set of memory. And then all of a sudden we've now significantly dropped the amount of memory space we have. But it's important to know, because if we don't do it that way, then we can get ourselves in trouble. Okay? So that's why I point that out. This will come back to haunt you. No, I'm just kidding. It'll come back, I promise. But I wanted to point it out because this is where we start talking about stuff like that. Okay? So, what other classes are out there? Remember when we had the scanner, what did we have to import?
Util.
The scanner, which came from java.util, right? Well, there's other ones out there, and in particular, the one we're going to look at next is this one called random. Okay? And as you can only imagine, I bet you could probably figure out how to build a random object. All you have to do is do something like this. Random, which is our class name. You give it your variable name, my_rand, equals new random. And that's it. Now you've created an instance of the random class. Now, when we want to use this, we want to get a random number back out, let's say some integer, we say my_random dot next int. And that will return to me, what do you think? Any random integer between what and what? Negative infinity? Negative what?
Negative whatever, like the memory thing allows.
That's right, whatever the memory thing that allows. So negative 2 billion something to positive 2 billion something, which is fine if you want that big of a number. But if you want to restrict that number, then we put a number inside of the parentheses, like say 10. Now, what do you think it restricts it to then? 0 to 10? 0 to 9? 1 to 10?
0 to 9.
0 to 9? You feeling confident? What's it doing in Python? Can you do multiples?
Yeah.
Right? This is going to be fun. All right. You're right. It always goes 0 to n minus 1. So whatever number you put in there, subtract 1, and that's the top, right? That's your max that it goes to. So we always start in the zero-based counting system in Java. Most languages are like that. VB might be the only one that did it for a while, but it does now. So now it goes from 0 to n minus 1. Now I'm going to ask you, what if you want to go between, say, 10 and 15? What do you think we're going to do? 10 comma 15? Well, hold on. We should find out if I'm even right. I'm just like writing this stuff down, and you guys are just going with it. So, which is nice. I think that's nice of you. I've been making all this stuff up this entire time, and you're like, sure. You have no reason to not believe me, I guess, so whatever. All right. Random number. I'll show you a little trick here in a second. Thank you. And then, oh, it didn't work because I didn't write it down right. but then we'll import this. Comes from the Java util as well. Then we'll run this, hopefully, and we get some number, which we're just going to assume is right. Right? You're down with it. All right. So, and if we put a number in between here, we can say something like this. We say, all right. Great. And we can run it a whole bunch of times. How do we know if we're right? Just keep going. Till you, because potentially we could get what? I don't know. 11? That would ruin everything. All right, so assuming that I'm not lying to you, and it's 0 to 9, that's correct. But you're saying I should just be able to say something like what? 10 to 15, I should go 10 comma 15. But now it does what? It gets angry. So now the question is, how am I going to do it? So put a 5 here, and then put a 10 out. Put a 6 in here, and then add 10.
Go do 5 and then plus 11. Because that's going to include 0.
How are we going to know if it's right? How do we know it's right?
5 plus 11.
How do we know that it's going to be right?
Well, if we know that next int's always going to give you a number between 0 and 5, or 0 and 6, if you're just adding 10 to that, then it's going to be any of those numbers. So I think it's,
What do we have to check, though? What are the two sides that we have to check? It's always the edges, right? What are our edge cases in this particular example? 0, that's 1. What's the other edge? 5. We only have to look at those two, right? If we assume that next int returns 0 to n minus 1, then 0 is the only one we care about, and it should give us 10. And if we go up to 5, it should give us 15, giving us our difference between, okay? Now, how do we generalize that? If I want to have any range, how would I generalize that? What would a formula be for that? Isn't this fun? This is like going back to math class. I want it to be anything. So what? You'd say next int. And then what do you suppose? Max minus min plus 1 plus what? Min. Right? Sound right? So that gives us our generalized version of anything that can be in between. Because you don't get the 10 comma 15. Yes, sir?
Yes, I was wondering, I assume you can insert a variable for the numbers in there from a scan.
Absolutely. That's the whole goal, right? Is since we don't know what somebody might put in there, hint, hint, your lab that's coming up starting tomorrow, is that you're going to have to get random numbers that say, I don't know, between 10 and 15 or 15 and 20. But the user might enter those numbers, right? What's the maximum of that number could be? What's the minimum that number could be? You have no idea, so you can't hard code in the number 6 and 10 because it won't work. So you have to be able to say, well, what's the max they put in there? What's the minimum they put in there? And then just put those in as variables. And then it'll still work. Does that make sense? Okay. So the other one that you have the ability to use is you can use what? Yeah, so you can do something like this. You can say my ran.next double or next float or next any of those. What do you think next double is going to give you? It will give us a decimal. Yes, that's very good. Between what and what? 0 to 1. What's inclusive? What's exclusive? 0 is inclusive. I'll give you that one. On the other side, 1 is exclusive. So it goes all the way from 0 up to 0.999999999 to get the idea, right? And that's it. So if you're trying to get a decimal on top of an integer, what would you do if you were you? You would just add them together. But knowing that if you are trying to get a whole number and you use a decimal, you're going to get 0.999. You're not going to get 1, ever. Okay? Unless you round it. Okay? But that is the gist of this one. Now, here's a different kind of class that makes it a little more fun. And it's what's called the math class. Okay? The math class is a special class in Java. One, because we don't need to import it. It just works. We get to just say math, and we don't have to say math, my math equals new math. Why do you suppose we don't have to do that? Remember, knowing what you know from Monday and now Wednesday, what are we doing? What is a class? A class is a what? What's the definition of a class? I'll keep asking this until you're like so tired of answering it, you're gonna like want to shoot me in the eye. What's a class? If you don't know it today, it's okay. You will know it eventually. A blueprint, a template, right? What's an object? Specific instance of a class. Okay. So if I don't have to create an instance of the math class, why is that? It is a static class, but why don't we want to create an instance of the math class? What is an object anyway, in general terms? Well, you were all walking around thinking about objects and classes, right? Between Monday and Wednesday? You were doing that, right? Yes. Just shake your head, yes, it's fine. Just entertain me for a second. Why do we create objects? What does that mean to create a specific instance of a class?
So you can use it over and over.
That's why we have classes. That's right. We're using them over and over again to create a specific thing, right? So think about the person, right? We have a generalized person, eyes, hair, arms, legs, and then we create specific people, right? Now, would you want to create your own specific version of math? That's sort of rhetorical. Right? No, you want math to always work the same way. Otherwise, if I say math, my math equals new math, I get to make my own math. Right? That means I could do whatever I wanted, and you don't want that. So you create what's called a static class where it can't be created. You can't create an instance of this class. This is a static class, which means all we have to do to use it is we say something like this. If you want to, I don't know, we'll say math dot, and then look at all the things that we have at our disposal. Notice, I don't know how many of you guys can read this in the way back, but at the top here we have a couple of constants. We have e and we have pi. So if you want to print that out, you can. And then we have all these methods that go with it, like absolute value. You have things like a cosine. You have decrement, cosine. You have floors. You have logs. You have maximum, minimums. You have things like, I don't know, maybe the one thing that you're supposed to do in your lab at some point, which is called power. Because otherwise you might try to use what to do something with power? Double asterisks? Is that what you guys did in Python? Here, what people try to do is they try to do that. They try to use the caret sign to do power. It will not work. That will do an exclusive OR, which is not the right answer. Let me just leave it at that. So how about we just do no for power? This is what we do. We do 6 and then 3, and then now we have something, we have 6 raised to the 3rd power. And it will return to us a double. And the reason why it returns a double is because we can also put doubles in there too. So we can go 6.2 raised to the 3.3, which makes it funner. Okay? What's that?
So, wait, what did you just say?
Right here, we can also put this as a double as well if we really wanted to.
Then you go to input like double into it.
We can put doubles here.
So like you don't need to literally type in double.
No. And the reason why is because what? When you call a method, do you have to give it its type? Did you? Well, you didn't have types in Python. You just sent stuff in, right?
Yeah.
So you just sent in the variable. Here, when you declare something, like you do like public static void main, you have to give it its type. But when you use it, you don't. You don't send in its type. Okay? by putting the number in, it knows what type it is. But what happens, do you suppose? What's happening here when I send in 6 and 3? If it's accepting doubles, what do you think is happening when I send in 6 and 3? What happened to those? They're being converted. How? It's a P word. They're being promoted. That's right. They're being promoted to doubles because by default they are integers. That's right. So they start out as integers and then they turn into doubles. Pretty cool, huh? So they have all sorts of things that you can use and you don't have to write them. That's the best part. You get to just use them. Somebody else wrote them. I didn't write them. And so they're just there for you. Okay, so use that to your advantage. Now, the other thing is there's classes that do both. They either have static methods in them, like the math class, or they have non-static methods in them, so you can still create an instance of it too. So for example, how we do that is we have the decimal format class. And somebody was asking about this at one point. We'll call this format 1. And what it is it's a class that allows us to change how we want decimals to look. How many decimals we want after the dot, or how many numbers we want before the dot. And so what we do is we say something like this, not so surprisingly, is we say decimal format, and then we give it the format that we want. So we say something like this. We say, oh, not that. We say pound dot 000. Okay. Now, when we import this, where do you think that's going to come from? Any ideas? Just guess. Java.util? Language? Oh, that's a pretty good guess. It actually comes from the text, which is close. So what's happening is we're changing text. That's why it's put into that library. It's a string text. And what this is, bless you, is in the constructor. Remember, the constructor is just the thing that constructs it. We will go through that next week in great detail. But that stuff in between there is telling it, how do I want it to look? Now, what do you think the pound or the hashtag, whatever you want to call it, is on the left? What do you think that means, those of you that read chapter 3? It is telling us that, but how is it telling us that?
Spaces.
Sort of. Any other ideas? Versus the zeros. That's why I put both of them in there. Then I'm going to mess with you after that. But we have these little hashtags in there, and then we have the dot and then the zeros after. What do you think the hashtags mean? Have you ever seen that before? We'll make notes. The hashtags mean that they are optional. That means if there are numbers there, display them. If they're not, do not display them. Does that make sense? So means optional. Versus the zeros mean, it means it will always go out to the third decimal place in this case, are required. Well, fill with zeros if nothing there. Okay? So in the case of, let's say for example, we're going to say, oh yeah, this will be fun. What am I going to get here? Just for fun. I just have to do it because I just want to know if you remember. What am I going to get? 0? 0.0? How am I going to fix that? See? You guys are so good. 1.0. We only need to change one of them, right? And then we can promote the other one. Okay, so we're going to format it to our format up above here. So now what should we see? We're going to see 0.333, 0.333, or 0.333. Yes, there's lots of answers. All right, here we go. Hold your breath. 0.333. And the reason why is because why? There was no 0 in the front, right? If we want to make sure that there's a 0 in the front, we have to put one there. Okay? So now it will always put a 0 there in the front. if we do this, what do you think is going to happen?
Zero?
Will I get 0.333 still, or will I get 0? There's a lot of muttering. That's cool. Why do I get 0.333 again?
Because it's optional, but there's something.
Yeah, it prints it regardless. Okay? So what happens if I do something like this? Will it put 3 zeros? Will I get 2 zeros and then a 0, or 2 3s and then a 0? Yes? I mean, I'm not getting a red squiggly line, right? It's totally fine with it.
The same thing. It's gonna be the same thing.
The same thing.
Same thing.
Same darn thing. Okay, let's see what happens. And then you tell me why. Because you read the book? I got an illegal exception. Why? There's an unexpected 0 in the pattern, 0 point hashtag 0. Why?
If the first and second decimal places are optional and they don't exist, then the third place does not exist either. So
Yeah, we can't force a 0 to be there if nothing exists here. These are optional, but we can't force one to be required. It won't be good for anybody. Hence, a runtime error. It doesn't check it at compile time because it has no idea until you create the instance of that class and then try to format. See what I mean? All it's doing when you create that instance is saying you're sending in any string you want. We're just supposedly putting in the right one, but it doesn't check it until we call the method format. So that's the difference, okay? And the same will apply on the other side, right? So if I put a pound out here, what will happen? Will I get an error still? No? You guys are so confident. I love it. It's Wednesday. So productive. And why didn't we get an error this time? Because that one makes sense. Because we can say, if there's nothing over there on the left-hand side, put a 0. And if there is something further in the 100th spot, then go ahead and put it there. But otherwise, just ignore it. Right? So, does that make sense? Yes, sir.
So if your answer were to be something that needed the tens place, would it?
Should we find out? Like that. So it prints it out. Okay?
So, since it only prints stuff if it's there, then the first hashtag makes no difference. It doesn't really do it.
The one in front?
Yeah, because it went 3 decimal places out.
Right, because it'll always print out the full answer. And then if it doesn't exist, then it'll only print out number 10, the 10th place, or the one place.
So that first hashtag doesn't really.
Not really. It's up to you.
Unless you wanted a 0 there.
Yeah, you could put a 0 there, but then you'd force the 0. Yep, absolutely. Okay? So that's the first way, your non-static way to access stuff. But if you want to call it a static class, then what we need to do is we have to do something like this. We'll create another one equals now, what we've done here is we've created another class, or we're using another class called number format. But what we've called is we've called a static method, just like we do like with absolute value, power, floor, all that stuff. And it's returning to us an object, a static object, that we can utilize to print out currency. Okay? So what that means is we can do something like this. And if we have something like this, we should see something in currency, which means that we no longer have to append the $ to the front. We can format it. What also this means is we can set the location, and so that no matter what location we're in, it puts the right currency down. by default it's in US dollars, but you can change that to different currency. Why does that matter? Because at some point you might actually build something for a different country, and it does actually matter. They care if you're in their currency. So, but it's a nice thing that you can do to make it a lot easier, and as opposed to just appending that. Because the other side is you may get something that calculates out to be like this, but you want it to be formatted in dollars and cents, not 4.545454, right? What are we going to get when we get that? 55?
$4.55.
54?
I think it round up.
Does it round up, or does it stay the same?
Depends on whose program it is.
Whose program is it?
It's the bank, so rounds up.
This one rounds up. Okay? That's that. Okay? So this one's a mixture between a static class versus a traditional object class. Class-object kind of relationship. Okay? Does that make sense between those three? Now, we have 13 minutes. We're going to do something that's going to be, hopefully it'll blow your minds. All right. So what we're going to do is we're going to start actually moving into the graphical side of things. Okay? So did you do any graphical stuff in Python? Turtle Christmas tree. That's right. All right. So there's no turtle. What you have in here is you have what's called the Java Swing library. Okay? This was written by somebody else. So it's just like random, just like currency format, or decimal format, that kind of thing. It'll have the same nomenclature, but you're going to do things, well, you're going to do it my way. And the reason why is I actually have a reason, and it's because your book makes you do it one way, and I don't like it because it's not maintainable. They shove it all in the same class, and it's not pretty. So we're going to separate the two out, and I know it'll look somewhat confusing at first, but I promise you if you do it this way, you'll have one class that you'll barely ever have to change, and then you just do all the other stuff in this other class, okay? So you'll just have to cross your fingers and trust me, all right? So what happens is you end up having two classes now that are going to work together, okay? So that's what we're going to do, and that's what's going to start happening when you create your own classes. You're going to have multiple files, and they're all going to start to work together with each other. So instead of having just one single file like we have been doing, we're going to have multiple files, and we're going to call those and use them. Okay, so we're going to call this one, well, I don't want this project, hold on. We're going to call a new class, we'll call it the main frame. Okay? Now, in Java, there's basically two things. You have the frame, and inside of that, you have the panel. Okay? So frame, and then the panel. They're both containers, okay? Hence, they contain stuff, they hold stuff. Inside those containers, and the frame is the thing that you imagine like this, that has the minimize, the resize, the close, all that, that's your frame. Everything that goes inside of that frame is your panel. They both can hold things, but the frame can only hold one thing at a time, whereas a panel can hold multiple things. Okay? Your frame is also called a heavyweight container. And the reason why it's called a heavyweight container is because it can run on its own. Like when you hit run, it'll pop up with the minimize and maximize and all that good stuff. Whereas a panel is a lightweight container. Because it has to be contained inside of something else. Panels can be inside of other panels. Panels can be inside of a frame, and so on. Okay? And then, on top of that, you have components. Those go inside your panel as well. Those are things like your buttons, your labels, and so forth. And then, when we get to it, we'll have events and event listeners. Not yet, though. Next week. We'll do that next week. We'll just make stuff show up this week. Okay? So, does that make sense? That's the Cliff Notes version of the beginnings of graphics. But to actually code this out, we have to actually create it. Everything you want to do, we'll start with a J for Java. I know, it's not very clever, but it is what it is. And then this here, what we're going to put inside of here is my first graphical program. Okay? That is what happens in the title bar. So what you see along the top where mine says like workspace and all that stuff, that's what I've created. We're going to import this, and it comes from the JavaX Swing library. Okay? And then what we do is we say frame.set default close operation. And what that means is when we click on that X button, we want it to close. So in order to do that, we're going to go jframe.exit on close. Now, notice that, what I just did in the middle there. Notice what type it is. Can you see that up above? Even tells you the answer and everything. It's an int, which means that it's what's called an enumeration. Okay? An enumeration is basically a bunch of numbers that they assigned words to. So you're restricting no domain. So you say, what's your favorite color? Well, there's blue, red, orange, and green. But really, it equates to number 1, 2, 3, and 4. But you don't want to have to remember 1, 2, 3, and 4. You want to remember blue, green, red, and whatever I said. And so that's what this is. It's basically saying jframe.exit on close. It actually associates to some number. That's all an enumeration is. Okay? So that's that part. Now the next part is where we actually have to add our panel. We haven't created our panel yet, so I'll just set that right here for a second. And then we have to say pack, which means pack my frame around whatever is inside of it so it all fits just right. Okay, so that's what the pack does. Now the last part, which I'm still not, I'm going to figure this out one of these days, you have to set its visibility to true, because by default its visibility is false, which means it won't show up. So you always have to set it to be true. This is the main part of any type of frame. If we ran this, it would actually show up with stuff, or it should. It won't look very pretty. In fact, it'll be just like that. Do you see it? Isn't that nice? Way up in the top right-hand corner, left-hand corner. Yeah, it's nice. Okay, so that's the first part. But we have to create a panel. And so in order to do that, we're going to say, we'll create a panel. We'll call it my panel. And now we don't have a main method. This time we don't have a main. This time we're going to create the stuff inside. Now I'm going to do some hand waving and some smoking here. Not literally smoking, but you know what I'm getting at. Okay? We're going to do what's called extends JPanel. You guys have actually already done it, you just didn't realize you were doing it. But we are becoming a JPanel. By saying extends JPanel, we're inheriting the JPanel class and thereby becoming that thing. Okay, so my class becomes that. Remember when I talked about constructors being the thing that builds stuff? We're actually going to look at it right now. This is what it looks like. It has to have the same name as the class, and that's it. That's all it's in. But it gets called first. So the moment I create my panel, that thing's going to get called. Okay? So what I'm going to do is I'm going to say set preferred size, new dimension. And what I'm doing is I'm setting the size, the height and width of the size of my panel. By saying that, I've created a new instance of the dimension class, which we'll come back to, which I think I misspelled probably, because I'm really bad at that. Okay, that worked. Okay, so then we have our preferred size. And if we looked at this now, if we were to add this panel, it would look something like this. My panel equals new my panel. Look familiar? It looks just the same as random or scanner or whatever other class that we've been using. It's just that I created it. So that's all that's happened here. And then to add it to your frame, you say set get content pane dot add, and then inside of there we add my panel. And that's it. So your frame should really only contain one thing, this stuff. It doesn't have to contain any more than this. And the nice part is once you create this file, all you're changing is maybe the name of your panel if you name it something else. If you keep naming it my panel, it will work forever. But you probably won't want to. But then if I run this now, remember how it was teeny tiny? Now look. It's not very pretty, but it's there. And if I expand it, there's my title at the top. Bless you. Okay? So we can do stuff like, say, JLabel, my label equals new JLabel. And if I say hi there, I can add this to my panel by using add. Notice I've never actually did like, remember how you have to do like system.out print line and all that? I'm just saying like add or set preferred size. It's because I am a JPanel. Because I am that, it's like I have those methods already in my class, even though I don't see them. And I just memorize them, so that's why I know they're there. But if you don't memorize them, all you have to do is say dot, and all of a sudden all of them show up for you. And you're like, where'd these come from? And they came from the JPanel class, okay? So, yes, you can. You're just being funny. All right, so what else is there? Now, once I add that, it should show up in there. But one thing I can do, notice how I do this. Why is it that if I were to do this, JLabel, what's that? What did I just do? Oh, not that. Hold on. What's that? What's that? What did I just do? What am I doing? Remember when I say javax.swing.jpanel or javax.swing.jlabel, what did I just do? I went into that library, or that folder. I went into the library, the Swing library, and then I looked for those classes, right? What if I wanted to just bring them both in at the same time? What would I do? Now, if I do an asterisk, that's what's called a wildcard character. Now, you can do that, but what have I done with that? What did I just do by doing dot star? I'm bringing all of Swing in, okay? So now, tell me which one's faster. The panel and the label. Why is it faster?
Because it's not putting everything at one time.
Yes, so we reduce the amount of memory because it's not importing the whole thing at the same time. And when it goes to try to find JLabel or JPanel, what does it have to do in this case? It has to search through the whole entire library. Right now it doesn't. So if you have each one of them individually, but it's sort of up to you. It's still pretty fast, but just know that. Now, those of you guys in the back might not be able to see this beautifulness, but there it is. It says hi there. Really, really small like. And we can change the font and make it bigger and all that good stuff. But that's how we add stuff. Now, if we wanted to add a picture, how would we do that? Tell me an example. All right, give me an idea for a picture, but it has to be PG. Nothing bad.
Goat.
A goat. Goat.
Not teaching stuff.
Hopefully. Please, please be good. Don't do anything bad. Okay, goat. There we go. Goat. All right. So to get a picture in, wow, this is going to be a really big goat. All right. A handsome goat. That's a nice looking goat. All right. So to get this picture, we have to save it to our desktop. To bring it in now, we do something like this. We drag it into our folder like this, and then the goat's there. But we haven't got it to show up yet. So in order to get it to show up, we have to use what's called an image icon. And then we need a path to it. Now, I'm going to just type the path in for now because we are out of time. But 741034, who named this thing? 3404.jpg. Now, why do you think it has that path? Why did I use that path? That is where the goat is, you're right. But why didn't I just put C colon / users, my name / workspace / January 31 / SRC / 74103.404.
Because it's relative to your home folder.
Yes, it's relative versus absolute. Absolute means start at the root, whatever your C drive is or whatever, and give the entire path. Relative means start at the root of my path, which just so happens to be January 31, root of my project, go into SRC, and then look for the picture. Notice what I entered in there. I'm not putting letters in there like hi there. I'm putting the picture in there. And if I run this, unless I typed it wrong, my goat shows up. And that's how the goat appears. If you don't have, wow, that's so beautiful. If you don't have the right path, it will not show up, and then you'll be sad. So make sure you do this, and if you send it to me with your absolute path, I will not be able to see it, because I will not have your absolute path, and I don't want to make all your users into my drive. So you want to use the relative path, especially when you deploy something, right? So that's the thing. So that's the things you're going to be doing in your homework and in your lab. So I'll post this online, so obviously you can have it, and then you can use it. But I'll see you guys in lab. It'll be posted obviously tomorrow. Let me know if you have any questions. Have a great day.